So welcome on stage, and that's your clip.
Okay, good afternoon. So before I start, I'm curious, like, who here has heard about FRRouting? Only half? Oh, that's disappointing. How many know about Quagga? Only about 3 more, okay. And how many of you actually have ever contributed any source code to an open source project, any open source project? Oh, that's good. Happy to see that one. Okay, so before I start, just to give you a quick introduction, my name is Martin Winter. I'm one of the maintainers from FRRouting. What we have is basically on the FRRouting committee, we have like maintainers. We also have like a TSC, the Technical Steering Committee. So maintainer is basically an open group. Anyone who is regularly committing to it basically can become a maintainer. There are about 20 maintainers right now on it. These are the ones who have access on Git for like doing the merges and stuff there directly. TSC is a smaller group, which is basically, in case there is like disagreements, how things happening, is like a small group elected once a year, where we have 6 people in there and which make the final decision if we cannot agree on anything. So far, in the last 1.5 years, that's only once which we ever needed to have a decision there. I'm also one of the key person who runs the CI system. So in this talk, I want to really bit less talk about FRRouting and give a quick introduction on it, but I really want to talk about what it requires from the testing point of view, what it actually takes from the time when somebody does a pull request until the whole thing is like merged into the code from like what's all going on there. So I'm one of the co-founder NetDev. We are like a company behind it. We are a non-profit. There are a lot of other contributors from various companies. There are about, I would say on average, maybe about 25 people working more or less full-time on FRRouting. And we're quite a large community. In the past, I used to work on Quagga. FRRouting was forked from Quagga. There I also worked in Cisco in engineering. That's mainly. So I used to live in the US the last 20 years. I finally had enough and left. So I also worked for a large ISP. So the quick introduction for the few ones who don't know what it is. FRRouting is an open source routing stack. I make routing stack in red because there is frequently confusion what difference between a router and a routing stack. A routing stack is basically the ones which runs the routing protocol. We don't touch the forwarding part. So for a full router, you need basically a routing stack, basically for the control plane, plus something for forwarding. You can run FRRouting if you want on a generic Linux PC or on an OpenBSD box, or just for other people in here, or like like random difference, like so basically any kind of Unix style operating system. And the other choice is also there are a few vendors which have like hardware forwarding, where you can basically connect it in, and then it will use the hardware forwarding of their like hardware. So we implement more or less about every routing protocol we can think of. And we're working to add more, the ones we can't think of yet, or the ones which are new, like getting developed or something, new standards coming out all the time. I mentioned already, it's a fork of Quagga, so we started about 1.5 years ago. It mainly was like a discussion there, how we wanted to change something in the, like the way how we run the whole thing. And we unfortunately couldn't agree with the person who owned the Quagga domain name. By now, basically everyone, with probably with the exception of 1 or 2 people, moved over to this project. And yes, say like it's used in a lot of networks, a lot of large networks who do not want to admit to it or don't want to publicly mention it, and a lot of smaller networks. There are like anything from smaller ISPs running it with like directly just on PCs, to a lot of people running on various white boxes, a lot of vendors shipping it on top of their white boxes, and basically in many different locations. I say the key thing for us was like when we built the community, we wanted to do really something which is in an open community like that. We wanted to make something where everyone can contribute to it, and it's like something which stays open. So we wanted to avoid that like one person or one group can control the directions or something. So we say like we have an open community there. We like open to any kind of contribution in general. If it doesn't hurt anything, we don't argue if it's useful or not. Basically, if there is any bad sign, we normally merge it in. If you write the code, we are happy to like merge it in. We don't question if this protocol nobody may be using or something like that. We also decided that we want to like automate and other things because from the volume there, before working on Quagga, we couldn't really manage the volume of patches coming in. It just didn't work. So we said like we really need to automate things and make it much faster. These are a few of the companies are behind on this fork. Cloudscale, anyone here from Cloudscale actually? Oh, good. So that is like one of the Swiss companies. I think that's the only kind of in Switzerland-based company on there. There, as I say, there are a bunch more who don't want to admit to it. And if you are like using it and you want to have your logo on the FRRouting website and mention that, you would be very welcome. So before going to talk, let's just give you a quick overview from some of the features. I don't want to go in all the details. There's just way too many things. I tried to condense, just pick a few very small ones of stuff which went on. For the ones you mainly know, Quagga, this is like what all came in since we took over from Quagga. So there is like things which came in, which like the whole LDP, which like if you have MPLS, which you can have on newer Linux kernel or with OpenBSD, then you can run a full MPLS router there. We had things like BGP EVPN, which came in, which is like a big thing, which a lot of people wanted. We have a lot of the BGP MPLS part, also with the Ethernet VPNs, unnumbered support, like on more or less most of the protocols came in. VRF Lite, a lot of JSON output for the ones who want to do programmatic output. That most of the commands, the normal CLI is very Cisco-like, but you can do like a JSON output there too. We also have more exotic protocols like Babel and EIGRP. Anyone still using EIGRP? Ooh, one, okay. Okay, so we added like later than segment routing. We added more like BGP VRF. There are actually two ways. So there is, if you use Linux, there are there's one problem. There's like classic VRF in Linux these days. However, that requires a kernel of 4.3 or 4.5 somewhere minimum for it actually to work. There is in the Linux kernel 3, which a lot of distributions or small switches have, you have network namespaces. So we decided to support that as an alternative. So you have basically the two choices what you want to use. We also have recently, just the one in October, we added BFD in there too. We added a few more like features in random other things. And the big work right now, which one of the things which already came in, Open Fabric draft, that's already in, but a lot of work on northbound and southbound interface. So the challenge is that classic on Linux, it goes everything like for classic Linux through the netlink layer for like forwarding table. If you have a distributed platform, that may not be the optimal case. So there is work in progress to change that to an API so you can attach it to any kind of hardware platform. And on the northbound, there is discussion, obviously, that a lot of people don't like a CLI. So there is work in progress for having a Yang interface, and then potentially together with that also have a real API where you can replace the shell with any kind of other shell. So if somebody doesn't like a Cisco-like shell and rather wants a Juniper-like shell, that should be trivial afterwards to do. Okay, so much about the classic, what it is. What I more want to talk today is like now about the work, what's going in. And I figured the easiest way is I go through the process, what happens from the time somebody does a pull request and Git until that whole thing is merged. I assume most people here are familiar with Git. For the ones not, you don't need for this talk to know much details. It's basically just the way how you submit a patch for a project. Yeah. A few key points on my work on the testing. There is like two things I learned, mainly also when I worked at Cisco, which did it completely different to this, the opposite of that. But in general, in open source, actually, you don't have the human resources, so you have to really automate everything. You cannot afford to do manual testing at all. A large company, like a large router vendor, may not care about adding a few extra people in some foreign country and have them manually pressing buttons, but we can't do that. And the other thing is also, it's not just automate the test itself, you also have to make the results somehow usable. Because we cannot expect that the people who submit something have the trainings or have a formal training at all to understand the output of the tests. So the output of the test should be clear enough that you know immediately what went wrong. And from my experience, from like writing the scripts for the testing, that's usually more work than writing the test itself. So I say, everything here, it starts with a simple pull request. So we look on GitHub, somebody decides, hey, I have some new feature written, and he does a pull request. So immediately when the pull request is done, the CI system basically gets triggered. There is like some webhooks in GitHub which do then send you automatic notification, tell you here, new stuff going on. At this time, I basically go in and try to build it. Again, the challenge is we support many different Unix-like operating systems, but most people who write code, they may test it on their favorite Debian or their favorite Ubuntu, but they won't really try all the different platforms. There's obviously quite a few differences there, just from the building point of view. So here are the operating systems I'm currently building on it. So if you look at it on Ubuntu, which is the strongest one, I gave up on 12.04 finally. I'm happy that's history now, but I'm still doing 14.04 and then 16.04, where we do it not just on classic Intel. I do 64-bit Intel, 32-bit Intel, 32-bit ARM, and 64-bit ARM, basically building it. And then also on 18.04. Same thing, CentOS. I'm still running CentOS 6. It seems to have quite a strong hold in some of the communities. It seems to be still very popular. I hope to get rid of it soon because it's getting really, really painful and very old from the packages. So it's not easy to build it on CentOS 6. Debian, there, classic there. We have like the 7 and 8 we have currently, 8 and 9 we have currently running there, so yeah. FreeBSD 10.11, which has finally got rid of the FreeBSD 9, which is like end of life for a long time. The challenge is, because quite a few people run it on this white box switches like the talk before on Arista with Debian 7 was that or something, which is like ancient. And trying to support some of these people which really try to run a better routing stack sometimes than what the vendor provides, or the vendor may actually use FRRouting. That takes us quite a bit some of the older systems. Then we also have NetBSD, OpenBSD. OmniOS is basically OpenSolaris. And Alpine, which we are like just about getting ready. There's like $1 or $2 left for like correct compiling for some of these things. So basically, I'm building all the packages there. I'm trying to compile it for each platform. Everywhere where we have package, then I go again, and I go build packages for all these platforms for every pull request, basically. These packages are only built for Linux. Basically, just to save time, I don't really do everything on FreeBSD for the testing. The idea is basically, I build the package, I use the same package as somebody else may use, or which will be published for my own testing. So I'm trying to avoid compiling it again for some of the tests. And then after this building, if that part actually succeeds, which is sometimes not that common, then we start with the whole testing. So on the testing, classic example, package tests. Can I install the package? Can I uninstall it without any error messages? When I install it, can I start all the different routing daemons? Do they actually restart correctly as they should do or something? Going through the start-stop scripts and all these things, trying all the different combinations for all these platforms. And then at the end, can I uninstall it again without like any problems? Very common if people add new things that this may go wrong. Then I do a quick protocol verification. I will get more in detail on this one afterwards, but I use a commercial test suite, Xia Anvil. This is like a software product which does like RFC compliance verification. So it goes through all the details there. And I do, in this case, only very basic things. My idea is just start the routing protocols, run 3-4 tests or something, and then stop it again and go for the next one. I cannot afford to do the full test here because that takes just too much time. So the idea is more like make a quick check that each protocol works. Then I have static analyzer. This is an old output. At the beginning was much more interesting. Static analyzer, if you do any open source coding or in general any coding, I can highly recommend. This is the Clang, which is like part of the LLVM, basically one of the C compilers. It gives you a lot of information about stuff which may go wrong. It may tell you like about things you haven't initialized, variables and other things. It gives you a lot of errors. You see some kind of small things. This was like at the very beginning of about the 2.0. Now I have to say we have 0 errors at this time. So all the errors were basically resolved. The other cool thing is if you never use that, it gives you a really cool output. I mean, it builds these web pages automatically. It gives you a really nice, when you click on the links, you can go with nice annotated how the path is, how very things wrong. So it's a really cool tool. Then the next step is basically we build some topologies and test these. So the challenge came in, there's a lot of newer routing protocols where there are just no test tools are available yet. Or there are some really weird, unusual things too. So we needed something, an open source tool where we can build whole topologies and verify if the function, if it works as we expect it to be. So this topo test, which is also on our Git, there, which we maintain and run it in parallel to it, is a simple way. It's based on PyTest. You can basically start it up. You can build topologies with multiple routers. I did up to about 100 routers in some extreme tests there and connect it together, build topology, see what happens, disconnect links, reconnect them again. It's based on the Mininet infrastructure below, if you're familiar with that one. And it does give some good indication and simulation there. And the cool thing, it's all open source. So if you go there, you can download it. If you write your own code, you can test it against yourself before you even submit anything. Yeah. It also gives you like nice outputs afterwards again. The next test also, which I'm running, is address sanitizer. Again, for the ones who are not familiar, you maybe heard about wellgrind, which seems to be more popular. This address sanitizer is actually a Google product. I think it came out from Google research site, which is really cool. Wellgrind is similar to it. It gives you like where you overflow buffers. It gives you like things when you free a variable and then you're still using it afterwards, and all these informations. The difference is wellgrind gives you a lot of false errors. This address sanitizer doesn't really, as my experience was so far, it never gave any wrong errors. The disadvantage is if it finds an error, it will crash your program with a lot of debug output. So you only find the first error and that's it. If you fix that, you may find then the next one. But I like it especially because I don't really have any false warnings and the output is really easy to understand. It gives you a really nice traceback. So classic, if you have like a free after use where you allocate memory, you free it and then you use it, it will tell you exactly here with a traceback, that's where I allocated it. Here in this traceback later, that's where I freed it. And then here in the traceback, these like calls, that's where you're going to be using it. So again, a very cool product. It's also much faster than wellgrind. There is some performance impact, but it's not that bad basically. I would guess it's probably maybe half to a third of the speed of the normal. Well, wellgrind could be much, much slower. So now when I have this test all done, then basically the next step is that my CI system posts back a result. In many cases, it may look like this. It gets back. So if you would be the person who does a pull request, you will get the response back like this somewhere. You may say like, hey, basically, it's sorry, it failed. And in this case here, was like it failed on the unit tests basically there. So like some of the building already worked, and then in some platforms it actually failed on unit tests. And you get some of the outputs exactly in there. The goal is, what I said myself, that within 2 hours, basically you should get this report. So all the testing before has to be done in less than 2 hours. That's just my own goal I gave myself, because I figured somebody who wants to submit it, he would prefer to get a fast feedback. The better case obviously would be if it looks like that, where it says successful. So the key thing is like up to this stage, everything is automated. There is no person that has to look at the code. So in our community, the idea is like if it doesn't pass the testing, the CI system, it's up to the person who submitted it to either go fix it or ask for help if he doesn't understand it or has problem. But in general, we just kind of ignore it to like save our time there. Once it goes through that part, then basically where we start with the first manual steps. The first manual step is really normally like somebody now finally has to do some code review there. So somebody will actually look at the code, make sure it's kind of nice. That's one of the cool features on open source code. It's normally much cleaner because people are afraid to submit things what they write for in-house code. Then it also, if there is obviously a question or issue, then you will go back to the submitter again. If they're like, hey, can you please clarify that? Or can you fix that? Can you change that part? Or can you add some documentation? Would be a good time to do. And once basically everything there went through, that's basically the time now when they can say like, okay, I can merge it. So it has to pass, somebody has to review it, and then it can be merged. Our rule, again, from all, it's any of the maintainers who can do the merge, but it has to be a maintainer from a different organization. So if I, from like NetDev Open Source Routing, write some code, nobody else from NetDev Open Source Routing, even if the maintainer is allowed to merge it, it has to be somebody from some different company. So that's just for us to kind of a safety rule too, that you cannot really push random things through. And there is the one case is if there is like the reviews, like if there's something like missing or there's a long discussion and we can't agree, or things just sit too long, we have weekly calls. Basically every Tuesday, if you're in Switzerland, it's about Tuesday, about 5 p.m. normally there, and where we have a 1-hour open conference call, where we go through all the open issues, make sure the ones which sit there are unassigned, get assigned and everything and resolved. The idea is, unless there is something big issue with bugs or not yet done, that within 2 weeks from a pull request, it should be merged. If there is disagreement there, if like one person says like, hey, we need to change that, but other people can't agree, and even at the call we cannot agree, that's basically when it gets pushed up to the technical steering committee. And now after the merge, well, obviously it's merged now, but you're not done yet, because now the whole game starts over again, basically. So now after merge, I start the whole testing again, but now this time even more testing. So it's again after the merge, the CI system gets kicked in, and they will test again. This time I add a few more platforms on the building. ARM7, maybe it wasn't clear, I normally skip that in the normal just because all the ARM7 systems I have are way too slow, and I can't afford 1.5 hours just for the building of the code. I'm also basically publish them again on the CI system, so anyone can download package for every single Git commit, basically for every time, when we did a merge a pull request. There is also an API version which we are building separate. Soon that will be just an addition module. We're changing the data structure, so that makes it easier. Then I run a full RFC compliance test, and that's one still a little bit limited, just on Ubuntu right now. That one runs, I think, had like about 4 virtual machines running for about 18 hours for like doing the full compliance test. So there are frequently multiple passes running at the same time. And the other thing is also Coverti scan. Not sure if you're familiar. It's another static analyzer. It's a commercial one, but it's free for open source project. However, they have a limit how many times you can run it. With our code size, which is just a bit less than 500,000 lines, they only allow us now 3 runs per day. So I cannot do it for normal pull requests. I just do it here. But that's basically, if you go down cover scan, you can look at the public statistics. One of the key things, which I'm really happy, is like our defect density, which is 0.11, which is way, way lower than the average on open source. When we started with Quagga, we were like more than double of the average on open source. And now we are like, I think, about a tenth of the average of an open source project. So we had a lot of things fixed there. So for the few people still running on Quagga, you should take this as a hint that you may want to change over. And now you're finally done after all this testing with the one pull request. We do this about 4 times per day. All this testing complete, like we merge about 4 pull requests per day. I'll give you an idea. So we have a few more less frequent tests, which we still do because, again, we cannot run it. We have the full compliance test. We have some of the reports I publish on the FRRouting webpage, if you go there. This is now running on like the full test multiple times because I also want to find issues when things are not stable and it's like unpredictable results. So here you see it all in passing, but you may see a red field for something failing. You may also see an unpredictable. And we do not pass all the tests. Some tests we have to fail to be compatible with Cisco. And some other things, obviously, we may not be perfect. I could tell you that if I will publish some vendors like this Cisco company thingy, it would have much more red in there. But it's something which we do there, obviously, for verification there. This test obviously takes a lot more resources that normally have multiple. It takes me nearly a week for running it through all the platforms with the multiple runs. We also do some performance and scale tests. These are a little bit less automated. There are also some of the tests which I do not run on virtual machines, because especially performance-wise, that may be not that predictable. So performance, I don't care on the forwarding. That's not our issue, because that forwarding platform is not part of our work. But what I do sometimes is really to verify like how fast does something converge. So if I bring up like 50 peers at the same time, how long does it take for converging things? So I may measure like the time until like the forwarding table is like correctly populated part. I may also simulate topologies, larger ones. So we use XE equipment for that. Different chassis which we have there with a lot of different ports and physical hardware. I also use sometimes a protocol Fossa. Not sure if you're familiar with that. You may have heard about Fossa. Protocol Fossa is a bit special. It knows the different routing protocols. So I have a classic example here. I show the BGP open message. The protocol Fossa knows how the protocol looks like. He knows, as an example, the version should only be 4 or 6. There isn't really anything else allowed. So the protocol Fossa will specifically try what happens if I try 5, what happens if I try 7, and what happens like if I do like skip that field there. In the autonomous system, he knows too which numbers are like not acceptable on something and tries to put all these numbers in. He may also try to have fields too short, too long, and all these things, all these different combinations. And the goal is of the protocol Fossa is if it basically crashes the daemon, or if it gets for some reason extremely slow, then it's basically a problem you discovered. The disadvantage, there is hardly any tools like this around. This is one very old system which we're using. There is about a very small market for all this like special protocol testing. Even the one I talked before, the XE Anvil, is a very small market, which makes these tools extremely expensive. I think a few $100,000, and also like frequently slow and not that well maintained. So this one is kind of physical box. I can only do 4 test beds at the same time. And for doing BGP testing, if I don't find any errors, it will take me a month for a full pass. So that makes it a bit painful here. I'm desperately looking for an alternative there. And heard some rumors about some new products, but I haven't seen anything useful. But anyway, all these things adds up, obviously, to a lot of work. To give you an idea how much the contribution is, this is about how FRRouting activity looks like. We forked in April last year. At April last year, there were about 3,900 commits in Git. 3,800 commits were in Git in Quagga. Before we forked, we added like a lot of fixes and stuff in there and everything. So we were about 6,500 when we announced the fork with the first version. And since then, you see that up. We are now about something more than 13,000 commits in there. If you look down there from the pull requests, which may say more, we processed more than 2,000 pull requests. So more than 2,000, the whole process I talked before went through there. And as I say, that comes down to approximately 4 pull requests per day, which get closed and like merged. So looking at from the resources to give you an idea how more of it, I went through it like this. Just from the pull request itself, basically, if I add up all the runtime from the VM, it ends up about, in this 1.5 years, about 21 years of runtime on VMs, basically crunching through the running tests. And then when it merged, there was another 13 years of runtime, and then the less regular bi-weekly release testing was another about 14 years of runtime. So it takes a lot of resources. So I actually run a few hundred VMs mostly across the world for like testing all these things. Still, if you're wondering how much is it worth, 27% is more or less currently. I would say it's actually kind of low, but about 27% of the pull requests, I can like point out errors before a person has to spend his time on it. And that saves a lot of time, basically, for the community. So the boring things, does it actually work, does it compile, it will really take that one down and make for the community much, much easier. Some of the big challenges there is obviously still we have some dependency on other packages. Our package is growing, we have a lot of features coming in, and we more and more depend on other packages. So now we use for the RPKI, we use the RTRlib, which is like another package there. And we are the first kind of large really user on it who basically uses it as is. So we started ending up having to help them testing too. We ended up that we had to start putting the build system up for them too, because they don't build for other platforms. They had some build system which kind of broke. Now they just asked me to officially help them to take over the testing for them. So we end up testing their products too. Now for the whole Yang, which we're just about in the process adding, it's again, it's a libyang. It's another product kind of a bit early. We are the first big user, so we start ending up to maintaining or testing and all that stuff too, building packages, publishing packages for it too. So that takes a lot of extra work there too. And also obviously, what platforms, there is no chance to test all the different platforms. It's really, I mean, we try to figure out which platforms people are using. We try to pick up some of the newer platforms. We hope to get most of it covered. As I mentioned earlier, the old platforms are a big challenge. It's sometimes amazing how outdated packages are. Anyone here still running CentOS 6? Yeah. So in CentOS 6, if you want to build our product, you end up first to build a new automake, then you build an autoconf, a new version, then you have to, I think there's another 2 or 3 packages, you have to rebuild it from scratch yourself, so you have the tools to build it. So, there is also a lot, sometimes the misunderstanding, there's a lot of companies sometimes think, oh, I'm helping out the community a lot with contributions by code. It's great. We love that when people contribute code. What many companies don't realize is like once you push code out, even if your code is perfect, it still needs to be tested or integrated in a CI because you want to keep it running, not just at the very beginning. So it takes a lot of work to add all the new stuff in there. There is frequently also documentation, a very big issue. I learned that lots of people like to write code, Nobody likes to write documentation, and hardly anyone likes to write any tests. It's unfortunately a fact. It's a lot of fun actually testing sometimes. It's a lot of fun breaking it. It's basically the key thing is also with all the new tests basically you need to add there. So keeping up that, new features coming out, new tests, all that stuff, that takes a lot of time. And if you ever publish any features for an open source product and you write new, please don't forget whatever open source project you work for it, give them help and with documentation a bit too, because for me sometimes testing, when people push new features but they have like zero example how that new feature should work, it's spending a lot of time trying to reverse engineer what they're actually doing. And that's basically it. I say all contributions are welcome. Contribution, work, money, anything basically, or just mention or public admitting that you're using it, that helps too. That's basically something how a lot of other companies look at it and seem to believe on how much they can trust the project to. Okay, questions? Wow, I answered everything. That's cool. Isn't that amazing? I got everything answered. Oh, not everything.
Claudius of VanGWorks. I wonder, where do you do the testing? Is it at some cloud provider, or do you have the computing capacity to do it yourself?
Basically, mostly my own computing, basically our own collocation, basically with our own servers. For a lot of the test tools, I can't even outsource it, because I mean you can find some VMs and other things outsourced, but the challenge is that outsource, especially when you go in the Ixia or something, some of these tools, some of them I cannot run outside house because of licensing issues. Some of the other things are these huge big boxes which take a lot of power, which you cannot afford really having it outside. There is also, even for the VMs, it's not so easy. The way I'm doing it is also that I run basically startup VMs at the beginning. So I have a fixed snapshot with a clean setup. So the nice thing is I can reset the snapshot, I can bring them up, do the testing, and afterwards basically throw all the changes away. I'm looking at it, doing some of the things on Docker there, which I'm not sure yet if it's faster. Because the problem is obviously still I cannot do all the platform, especially if I completely different like distributions. Like I cannot really do a BSD testing really on Linux or something. And also for the hardware, basically the ARM ones, these ones are actually collocation providers, provides ARM boxes, which I'm using for that. So I'm using physical boxes, not like simulated that part. Again, building I think would work, but testing on a simulated ARM, I'm not sure if that's reliable.
Thank you.
Okay, then thank you very much, Martin.